Alright, since I didn't find an English video that suits my demands here on our lesson, I just take the German video and I'm going to translate the text and well, explain things in a little bit more detail. That's good anyway. So this video is about a spring that moves, that has a little mass attached to it and is deflected by a certain distance, and then it starts oscillating. So the mass is moving up and down. For the explanation, that's what we do later. What we want to do now is just observe what is happening there to get an idea which, if the mass, for example, what influence does it have on certain values that characterize the oscillation. So I'm going to start now. And here you see the basic oscillation that is described here in a time graph, and the text just says that with an easy experiment you can observe certain things. So the bigger the mass, the longer the period, and that's what you can see here. So on the right side is a small mass, and it's the frequency or the period is very small, so the frequency is very big. However, the deflection has no influence on the frequency and thus not on the period. That's what you could see there before. So this is going to take some time, so I'm just reflecting on the last one. So if it doesn't matter how much you extend the spring, when you look at the period, it always has the same period. So the period depends on the spring itself and on the mass, but not on the deflection. And here is a video. There you can see that how this is recorded. So what we saw first in the first picture is, well, kind of proven here. That's the graph of the distance over the time, and by distance I mean the height, for example. There was a sensor on the ground and the height is changing constantly, and this already looks like a sine curve. We go back a little bit. Here again you can see the effect that the period is the same, independent from the deflection. And this is the damped oscillation, and well, this is kind of boring, but what we can see here is already that when you measure the distance between that sensor and the ball that is oscillating, it's going up and down, and this curve looks pretty much like a sine curve or a cosine curve. Yes, there are many ways how you can investigate this, but what the graphical, what this is showing is that the amplitude, so the maximal deflection, is getting smaller with the time. And this is, of course, due to friction, that energy is going out of the oscillation. And that is already something we can keep in mind, that, but this is quite obvious. If the deflection is bigger, we need a bigger force at the beginning to move the mass out of its equilibrium. And well, when energy is moving out of the system, then the amplitude is getting smaller, and that's what we normally have in reality.